Okay, let's start with the branch instructions next. Okay, there are four branch instructions. B, we have already studied this. Okay, we have already studied B. Condition label. So we have seen certain conditional execution examples, like for example BZ branch F0. Okay, so I'll just write it down if you haven't understood what I've told. BZ, then BNZ, this branch of not 0. Okay, then we have also seen BEQ, that is branch of equal. Okay, so I hope you have understood. So B stands for the instruction, EQ is nothing but the condition. Okay, so here that is the first. Okay, the second one is branch with link, you can see here, and BX is nothing but branch and exchange, and here it branch exchange with link. So these two instructions, that is BX as well as along with BLX, is something whenever we use the thumb instruction set. Okay, so we use these two, otherwise these two are not used. Okay, so you all know what is branch instruction. If we use branch instruction alone, it becomes an unconditional jump. Okay, and if we use branch along with the conditional, it becomes a conditional jump instruction. As you can see here, when the branch instruction is executed, it has more to do with the PC. Okay, where PC stands for program counter. So program counter always holds the address of the next instruction. Okay, so when you need to branch to a particular address, that address is nothing but the label. That label is nothing but the 32-bit address. Okay, and that address is actually loaded to PC, the 32-bit address. Yeah, I'll repeat. So branch with link is nothing but like a call instruction. So whenever you want to call a subroutine, we'll be using branch with link. As you all know that the name link suggests the link register. Okay, you can see here. So it's this one thing is the 32-bit address is loaded to PC program counter, and one more thing is the address of the next instruction or after the BL. So let's say assume that after BL there are certain instructions. Okay, so the address of that next instruction is actually stored to the link register. When we had studied link registers, uh, when we were going through link register, we had actually studied that, right? That what does LR store. So that's what happens. I hope this concept is clear. B is nothing but it can be a conditional jump or an unconditional jump. BL is nothing but a jump or a call to a particular subroutine, whereas BX and BLX is something to do with the thumb instruction set. So whenever we use the thumb instruction, which we are not going to use it, okay, then we use BX as well as BLX. So the internal working is actually given here, but it's not possible to understand very clearly if once the thumb instruction set is done, then only you'll understand it, which we are not having it. Okay, so here is another example of branch instruction, the forward jump and the backward jump. It depends on where you place the label. B forward, after certain instructions here you have placed forward label here, so nothing but you can see that once the B forward is executed, it jumps to this particular address, this particular instruction, skipping these three instructions. Backward jump here is nothing but B backward. So here nothing but it's like used as a loop, right? Here jump is nothing but used to skip certain instructions. Okay, so and here it's nothing but for looping. So you can see here the forward branch skips three instructions, whereas the backward branch, it creates an infinite loop. So depending on what you are writing the program on, okay, what is your application, we are going to use forward and backward jumps. Okay, so this is the next instruction, that is BL subroutine. That's what I was just telling you, right? Okay, so remember that whenever you call to that particular or go to that jump to that particular subroutine, whenever you want to return from that subroutine, you need to what, load back that to PC. So here you can see here BL subroutine. Okay, so the moment you see VL subroutine is, it is going to call to that subroutine here. Okay, it is going to execute certain subroutine codes. Okay, and the last sentence will be, or the last instruction will be move PC comma LR, meaning to say that whatever is stored in LR, whatever stored in LR was nothing but the address of the next instruction after BL, right? So this address is actually stored in LR, and that will be moved to PC, because whenever a branch instruction is executed, this address, subroutine's address, will be moved to PC. Right, now when you want to come back, the LR's data must be copied onto PC so that it comes back here. I hope this slide is clear to all. Right.